will. Awesome. Well, good to see you all. Thanks for coming. Happy Tuesday. Couple of things that I wanted to do today. The big one being wrapping up 4.5. I want to kind of put a bow on it, be done with it today. And so what I did was put it all together all in one place so that it's really easy for you to have a guide. Now, this is not something you have to have stuck up here right now or anytime soon. It's something that I want you to realize you can use over and over and over again until you start to get the hang of it. And you're going to work on it today. So there's kind of two sides to this, and I know it might be not super easy to see, especially if you're walking in front of it and walking back and forth. But there is a photo of this up on the announcement for today, all in one place, so that you can do both things. You can go, so given an equation, you can graph it, or given a graph, you can come up with the equation. And so there's a couple things on here that I really want to make special mention of before I tell you what we're going to do with it. Number one, I tried to organize it in terms of like the order that I like to do things in. So there is like a 1, 2, 3, 4, 5, 6 and a 1, 2, 3, 4, 5, 6, 7. I put a little, I forgot to put it in there, so I had to put it up here. But factor out B if necessary. So call that step number 0 if you think you need to. But kind of giving you a really good strategy on how to do it. That if you're given an equation, we kind of want to do what we have been doing by writing down A, B, using B, of course, to help us find omega, to find the row period, C over B, and D, right? And then we can, depending on what we're starting with, right? For sine or for cosine, I'm going to plot a starting point, but they're going to be in different spots, right? For sine, it starts at D. For cosine, it starts at D plus A. And then finding an ending point, which is a distance of omega away, which will be at the same y value as we start. And then, like, my strategy from yesterday is kind of what I'm writing down here for 5, 6, and 7, is to find the midpoint by averaging those x values between the start and the end, and then giving you a heads up for like where the y value is going to be for that. And then between the starting point and the midpoint, you're just going to find the average of that to find the x. And then for sine and cosine, you've got y values. And then between the midpoint and the ending point, I didn't, like I said, I called it like the next point or point number 2 and point number 4. I don't really have a great name for it, so I just kind of said it like that. And then where those y values are going to be. And then I gave you a progression for those y values for sine or for cosine, right? D to the top, midline to the bottom, and then back to the midline, or top, middle, bottom, middle, top. Okay. This we haven't done quite as much of, so I really wanted to take a second to talk through if you are given a graph, and you're going to be given 4 graphs today to try to come up with equations. How are you going to come up with an equation that works? Now, no matter what you choose, the amplitude for a given function is whatever that amplitude is, right? The frequency is what it is. The period is what it is. The midline is what it is. But you get to pick a starting point for sine or cosine that works for you, right? As long as you're choosing for sine a starting point that starts on the midline and goes up, you might have a lot of choices for that starting point. Right, you saw when we messed with that frequency yesterday, and I really accordioned it down, right? We had a ton of cycles, and you can pick any of those starting points to begin. Same thing for cosine, just pick a maximum. But when you choose a starting point, make sure that if you can, that you pick a starting point that allows you to see the end point as well. If I'm going to start here, I want to make sure I can get myself through a full cycle, whether it's starting at sine and going up, back down, and coming back, or starting at cosine, so you start at maximum and you work your way back down. I don't care which starting point you choose. So there's actually a lot of freedom there to pick whichever one you want. But just make sure that you can find the endpoint of one of those cycles, right? Now, here's the thing that we haven't done yet. We've been able to say, okay, if I see B in an equation, I can find the period by doing 2 pi over B, right? Well, now we're going to have to go the other way. You can't necessarily look at a graph and see the frequency, but what we can do is measure the period, right? Because if I can start and end a cycle somewhere, I have a starting point, I have an ending point. If I know what those points are, I can figure out the period by measuring that distance, right? To measure distance along points along the x, like kind of an x direction, all I have to do is subtract those x values, right? Think about it. If I have a point that starts at 1 and ends at 5, right? So I've got a starting point at 1 and an ending point at 5. The distance between those from 1 to 5 is 4, right? 5 minus 1. And so if I take my ending x value and I subtract the starting x value, that will give me my omega. That'll give me my period. And how does that help me? Well, if omega is 2 pi over b, then b, the frequency, is 2 pi over omega, which you can just solve for by manipulating this equation. You can just multiply both sides by b and then divide by omega, and you're there, right? And I don't know if you knew this, but this is a super nice shortcut that I use all the time. If I've got one thing and it's equal to a fraction, and I want to solve for the denominator, all I have to do is switch those two, right? Which you just solve for algebraically. Multiply by b, divide by omega, you would get yourself to here. So what we've got, because I got to figure out like what a is, what b is, what c over b is, and what d is. Well, a is really easy. So I just look from the midline to the maximum. I just count boxes, right? C over b is not that bad because it's just my starting point, right? I just pick a starting point, whatever that x value, right? D is the midline. The only tricky one, I think, in looking at a graph and coming up with the equation is figuring out what the frequency is. And now you've got a super easy, nice way, a formula, 2 pi over omega, and that'll get you B. And if you've got like kind of your x scale is in radians, right? And you've got pi and pi over 2 and 3 pi over 2, stuff like that, then your omega is probably going to be in terms of pi, and your pi's are going to cancel. And you'll get a nice integer for that spot, which is what we're hoping for most of the time. Okay. So this picture, a picture of this is on Canvas, right on today's announcement. So have that open. I would suggest writing it down sometime today. You don't have to write it down right now. I'd rather you practice, right? And that's what today is. Today is a practice day. But I did want to do one other thing first, okay? Because there's so much cool stuff that we can use with trig to better understand it, or like just kind of, I don't know, just be fascinated by the world. And so I have a video that I want us to all watch together simultaneously, but separately from home. So I'm not going to share my screen because it gets kind of choppy when I do that, to watch a video. So what I want you to do is I want you to go to today's announcement. I want you to click on the link that says, whatever it says. Where are we? Let me go back to my thing here. Today's announcement, the fun and fascinating video or something. Yeah, fun and fascinating video. Now, so what you're gonna do is you're gonna open it. There's a pretty good chance there's an ad at the beginning. So just, get the 5 seconds through and skip it, and then pause it at the beginning so we can all start it together. Because I want to talk over it while you're watching it to help you, and we're gonna pause at some points throughout so I can explain what's happening, okay? So that's what I'm gonna do. I'm gonna go back to my computer right here for a second. I'm gonna open up that video. I'm going to mute the video on my side. Your microphones are muted, so you don't have to worry about muting your actual YouTube itself. Let's see if it mutes it before the ad starts. Yeah, nice. So I've got a Verbo. Maybe you get like a Grammarly. There's so many of those constant YouTube apps. So I'm gonna skip my ad and I'm gonna pause it right away. And I'm going to give it a chance to buffer a little bit so that it loads. Okay, it's only a 2-minute video, but we're going to stop at a couple points. So hopefully you're at the point where you're at 0 minutes and 0 seconds, and it's starting to buffer a little bit. What I want to do is show you something I think that's pretty cool. Okay, now what you're looking at on this video is not something that we can see with the naked eye. Okay. It's not necessarily a camera trick, but it is because of the camera that we're allowed to see this, that it creates this image for us. Okay, so I'm going to have you play here in 1 second. And just a couple seconds into the video, what you're going to see is it's going to set it up for us. And there's going to be these words in yellow that come up that explain what we're going to look at. And I want you to pause right there. So in a second, we're all going to play the video, and then we're going to pause. Like just a few seconds into it so I can explain what the setup is and why the setup is the way it is. So that's what I'm gonna do, okay? So in 3 seconds, I'm gonna count down. 3, 2, 1, let's just play it, and then we're gonna pause it in just a few seconds. All right, so 3, 2, 1, play. Black cat walking across. Okay, see the little setup with this, like this tall, okay, cool. I'm gonna pause right there. So I am like 6 or 7 seconds into this video, and it has those words there in yellow, right? And so here's our setup, okay? There's a big speaker, okay? And there's a rubber hose that we're going to attach to a water source. So we're just gonna plug it into our spigot outside, okay? Now, through that speaker, we're gonna play this tone that's gonna just stay constant all throughout. We can't really hear it all that well, but what you might hear if you turned your volume up, it would be like, boom. Like just this kind of this monotone sound, okay? And that sound is at 24 hertz. Okay, that's the frequency of that sound. Remember, sound moves in waves, and when we mess with that frequency, we are changing the pitch of the sound, right? And you can kind of tell, I don't know if you've ever done this before, but if you put your hand on the middle of your neck here, so from putting it on my Adam's apple, I can feel my vocal cords vibrating when I talk. And the lower my voice goes, the slower it's vibrating. And the higher my voice goes, the faster it's vibrating. You might not even be able to feel it if you have a high pitch. Your vocal cords vibrate. Okay, and they vibrate constantly at certain tones, and it produces certain pitches. Remember, volume is amplitude, right? Frequency is pitch, okay? And so what it's gonna do is gonna maintain the same pitch all the way through. 24 hertz, okay? But the camera that they're using is 24 frames per second, okay? And when we're watching videos, you're not actually watching a video, you're watching a sequence of pictures that are kind of spliced all together, produced at a certain rate so that it appears that we're watching something happening live, right? Our eyes work way faster than 24 frames per second. I'm seeing a lot more images, a lot more light is entering my eyes than just 24 frames per second, okay? And so that's kind of the trick. 24 hertz, 24 frames per second. Now, so off the top of my head, I can't remember exactly how many frames per second our eyes are feeling as we look around the room. But what I can tell you right now is that although it's going to be super bright, probably if I pointed at it, but that light right up there, that fluorescent light right there, although it looks like it is constantly producing light, it's actually blinking at 160 times per second, something like that. I might be making that number up, but it's a lot faster than 24 frames per second, okay? And that's why a lot of people that work in office buildings or you guys spend all day in school, some people complain of headaches. It's because although our eyes can't catch it, our brain does not register the blinking, our eyes can feel the light going on and off, on and off, on and off, on and off, and it causes headaches because of the strain that it puts on our eyes. So a lot of people work in office building complaining of office headaches or that fluorescent light headache. It's because the light is blinking. And maybe you've seen it when the fluorescent lights start to die. I can even see it right now on my screen. I don't know if you can see it. My screen is kind of blinking because the bulb in there is starting to die. Or if you've ever watched let's say a sporting event and they go in slow motion, the screens in the background, maybe the advertisements or the big video, Jumbotron, it looks like it's blinking. It's because it actually is. It's actually blinking, but our eyes don't catch it because it's blinking too fast. When we slow it down, then it is. Okay, cool. So that's the preview. All right, we're gonna be ready to play here in a second. And I'm just gonna talk through it. We won't have to pause for a little bit. I should be able to talk over it, okay? So I'm at 6 seconds. Maybe you might be at 7 or 8, that's okay. I'm gonna play in 3, 2, 1, play. Okay, so here's the setup. It takes another second or two to show you that. So there's the hose that's attached to the speaker. They're going to turn the water on, and then they're going to turn on the sound. Okay, so there's the water flowing out, and it's going to be nice and consistent. Now they're going to turn on 24 hertz. And what you are seeing right now is nothing we can actually see with the naked eye. What's happening is the hose that's attached to that speaker is shaking back and forth this way. But it's shaking back and forth 24 times per second. And what's happening is that the camera is catching. You can see them like turning the sound on and off. The camera is catching the wave of the water moving out of the hose at the exact same spot every single time. So you can kind of see like the water shaking around a little bit. We're going to pause here in a second, so be ready. You can see the water kind of shaking out. All right, pause right here as soon as it says 25 hertz. Okay, so I want to talk about that for a second, right? The water was coming out like this. Okay, but what's happening, and I'm going to slow it down a little bit, it's going way faster than this, but the camera is going click, 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 click at the exact same height. And so it's taking what seems like the same picture over and over and over again, which gives the illusion of this constant sine wave, this more like a spiral because in 3 dimensions, that just pauses at every single spot. But if you turn up your volume, you can hear it hitting the ground, which is pretty crazy. And it's because it's 24 hertz and 24 frames per second. Okay, the next one, I'm at a minute and 7 seconds, just about. They're gonna turn the frequency up just a little bit. So they're gonna go to 25 hertz, but we're gonna keep the 24 frames per second. All right, I'm gonna unpause. I'm gonna play in 3, 2, 1, play. Look what happens when it's 25 hertz, okay? Now the camera is catching it. You can see the hose, it appears to be moving in slow motion. It's actually moving much, much faster than that. And you can see like as they zoom in and out, it's not happening in slow motion, but it looks like it's happening in slow motion because of where the camera is catching the movement. It catches it at the top, and then it catches this like just after that, and just after that, and just after that, and just after that. And it gives this illusion of the water moving in slow motion. When it gets to 23, stop right there. So I'm at 144. This is the coolest one. Okay, so I'm at 1 minute and 44 seconds. What if we backed it up? Just 1 hertz. 23 hertz per second. This is the best part. Go ahead and unpause, play it. This is not in reverse. You are not looking at this video happening in reverse. Water is still flowing out, but it's taking a picture just a little bit earlier in the period of that vibration through the hose. And the water appears to be going backwards, which is just so cool. But if you turn it up, you can listen to it, and as they turn it off, and you can stop right there. I think the video is just about done. And you can watch it again and again. You can back it up to that 145 spot. You can hear the water hit the ground. And what's so cool about that is that although our eyes see one thing, our ears are telling us something else. And you can make that. Like how easy would that be? You just need the right kind of software to create that motion. And that's like the beginning of like, once I saw that video, I was like, this stuff is so crazy cool. Like I was so fascinated by that like that's where you enter the YouTube hole, right? That's where you go down the rabbit hole and you find some crazy, crazy cool stuff. And so I've got a couple other things that I'll show you here in the next couple of weeks. I might have to just show it to you tomorrow because it's so cool. But the visualization of that kind of stuff is what makes it so interesting and really, really cool stuff. So there you go. Pretty awesome. Okay, share that with whoever you want if you want to melt their brains a little bit, especially that reverse one. There's another video that's a lot longer that explains why that stuff works. So I'll share that with you. We probably won't watch it necessarily in class, but maybe I'll send it out to you and you can watch it. It's like 13 or something, 13 minutes long. Cool. All right, so pretty cool. Hopefully you like that. Today, I want you to do your thing today. I want to give you the freedom to choose what you want to do with our last half hour here. So here's what I did. On today's announcement, there's that, right underneath the Google links, click here for your work for today, okay? I wanted to give you a chance to practice both sides of these, okay? We've done more of the graphing than we have of coming up with the equations. So you see there's only 2 graphing ones, and there's 4 of these. And I wanted to give you the freedom to do it on your own, okay? But what that means is that if you open up that classwork or homework, I call it homework 4.5b, you've got these notes to help kind of guide you through. And of course, you'll see within that, I tried to explain how to do some of those things, especially in part 1 and part 2, especially part 2, what you're looking for. Okay, when you get to part 3, it's very similar, so I took some of the notes off. But you have this to look at. And so here's your freedom, okay? I know you guys have been on the computer a lot, these Google Meets, and having to look at a computer and look at a screen and like camera on and focus and do all that stuff. I want to give you some time today to do your thing. What that means is that if you want, you can log off this Google Meet and do this work. It's due before midnight tonight. All right, so you have the freedom to do it whenever you like, right? However, if you want to stay on and get it done, great, I'm going to stay here, right? I'm going to keep my camera on and I will answer questions and walk through some stuff. There were a handful of people that stuck around during second period, and I went over to the whiteboard and helped them work through some of the things that they were struggling with, both part 1 with like factoring out B, or part 2 or part 3, and figuring out like what starting point should I choose, and how do I measure the period, and then how do I find the frequency, and how do I know where the midline is, and all that kind of stuff. A handful of people stuck around and they asked those questions. Or maybe you say, you know what, I'll stick around, but I'm just gonna work. And if a question comes up, great, then Rosie's here to help me out. And if I don't have any questions, then I'm just done and my math work is done for the day, okay? Or you can say, you know what, I'm gonna log off the Google Meet, I'm gonna do my thing, I'm gonna stick around and work, but I'm just not gonna keep my Google Meet on. And if I do have a question, maybe I'll hop back on, and I know Rosie's gonna be there until 11:15 to help me if I need. Okay, but you have the freedom to do any of that. Do not stick around if you don't want to, okay? You can go. If you want to go right now, I'm good, okay? Just make sure that you get that homework 4.5b done and submitted before midnight tonight. Tomorrow, first thing, I will have the answers posted, or at least up when you join the Google Meet, so we can look at them, make sure you feel pretty good, and then 4.5 will be done, okay? So stick around if you'd like and get the work done with me. Log off and come back if you have questions, or just log off, do your thing, and I will see you guys tomorrow. You guys okay? Cool? If you're leaving, see ya. If you're sticking around, let me know how I can help.
Thank you.
Bye guys, have a good one.
Mr. Rosenberg,
What's up, Em?
I'm confused on how to find the C over B.
Okay, so like a part 1 kind of thing, or a part like from an equation or from a graph?
From a graph.
Okay, so let me share my screen so I can pull up the homework, and then I will point to some stuff, and that might help you. Now, the thing about C over B is that, and I kind of said this, but I'll reiterate it so it's clear, that you have some freedom in choosing where you want your starting point to be. And that's the key, is that C over B will always be that beginning point of one cycle, okay? Now for sine, when I'm looking at a sine graph, so like number 3 and 4, so all of part 2, I'm looking for a point that starts on the midline and goes up, right? Because that's how like a regular sine graph starts, okay? For cosine, I'm looking for a maximum. I'm just gonna pick the highest point and then I'll work my way through. And so when I look at a graph like number 3 here, I've gotta find a point that's on the midline. And so I kind of need to be able to see where the middle of the graph is. And hopefully you can kind of see that it looks like the x-axis is kind of where the middle of this graph is happening, right? Do you see that?
Yeah.
Cool. So I know that I've got like a bunch of different points that sit on that midline, and because it's sine, that's the kind of point I'm looking for. But I'm looking for a point that starts on the midline and goes up. So I don't want to choose this one because it goes down, right? I don't want to choose this one because then it goes down.
Okay.
But if I look at, let's say, this one right here, the other thing I want to be able to do is that if I'm picking a starting point, I would really like to also be able to pick an end point, like, you know, at the end of that one cycle. And so if I pick this point right here, I don't see the other half. Like this part of the graph, there's no space for. So I don't really love this as a starting point because I can't see one full cycle.
Okay.
I think this point right here might be my best choice for a starting point because it starts on the midline, it goes up from there, and I can see one full cycle of sine starting here and ending there. So for me, a C over B for number 3 that I really like is that negative pi. I think that that x value of negative pi is going to make a really good C over B.
Okay.
And so when I pick, so like the last thing I'm going to do is I'm going to write down the whole equation. But what I know is that right here, that C over B is going to be negative pi. So I've got theta minus negative pi. So really like theta plus pi will go on the inside right here.
Okay.
And that for me is one of the hardest parts, is picking that perfect, great starting point. But what I'm going to show you right here is that if you look at number 4, right? So all right, it kind of looks like my midline is up here at 1. But because like all right, there's a starting point right here and it goes up, down, and back. Okay, so that would have made a good one. Or what about this one? It goes up, down, and back. Okay, that's also a good starting point. Or here, up, down, and back, right? I've got a lot of really good choices, I think, for that starting point. And so you've got the freedom to pick whichever one you want. Usually, I'll pick the one closest to the origin.
Okay.
Right? So if I can pick 0, great, because then it's just theta instead of, you know, theta plus pi or theta minus pi over 2 or something like that. I don't have to worry about a phase shift if I can pick a point that starts on the y-axis. But you've got the freedom to pick any of them, whichever one you want. But I try to stick near the origin as best I can if I can see one full cycle so I can find the endpoint that goes with it. Because if I want to figure out the period, I need both, right? I need a starting point and an ending point so I can kind of measure that distance, because that'll give me omega, which I can use to figure out what number is supposed to go right there for B.
Okay. That makes sense. Thank you.
Yeah, sure.
Mr. Rosengren.
What's up, Gracie?
Well, for part 1, so like I found all the transformations for the 2 functions, but then it says graph the function from negative 2 pi to 2 pi.
Right. So like on our blank trig graphs, that's the space that we've got, right? Our x-axis goes from negative 2 pi to 2 pi. So just kind of giving you a guide that says try to plot as many of those cycles as you can in the space that we've been graphing in.
Okay, thank you.
And so what I would do, right, if I'm graphing, right, I figure out all this stuff. And if you're looking at like number 1, okay, it's a sine graph. So I pick my starting point and I put a point right there. Then I go to the end, which is a distance of omega away. I'll plot my last point. And then I just start finding middles, right? Okay, I'm going to find the midpoint between those two. The x value will just be the average of your two x values that you've got so far, right? You're just going to find the middle, which you can just like count boxes to find the middle, or you can actually add them up and divide by 2. Because it's sine, the y value will be the same as your starting point and end point. When you get to the cosine one, it's going to be different because of kind of like the progression of cosine where that happens. And then I find the point between those two and the point between those two. And that's all I really need is I find those 5 points. And then I can kind of like just continue that, you know, kind of by copying points to the left and to the right as best you can. And sometimes they ask us to graph 1 full cycle. Sometimes they ask us to graph at least 2 full cycles, usually depending on the frequency, depending on the period. Because sometimes you saw like when we did, I don't know if we did it yesterday, I think it was yesterday, we did like cosine of like 1/2 theta. And it took me the whole space to use, you know, because it was half theta, right? I needed all of that distance from -2 pi to 2 pi just to get 1 full cycle in, and that was my 5 points. The bigger your frequency, the more points you're going to be plotting. The smaller the frequency, the fewer. So just plot whatever you can as best you can using this kind of strategy and following that progression from point to point. And if you are like sitting there and you want me to look at like, all right, did number 1, you want to, I can look at it and see how it looks. Or I can graph it on here and you can compare yours to mine. I'm happy to do that. Just let me know. I'll have the solutions first thing tomorrow morning for sure, so you can check them. But if you want to see if you're doing it right, or you know, a part 2 or a part 3, if the equation makes sense, I'm happy to check that. You guys are here, so let's do it. Otherwise, we can just wait till tomorrow. That's cool too. What do you guys think of that video? Was that kind of cool? Right, it's super cool. And that's like the beginning, like that's the tip of the iceberg. I've got one tomorrow. I think I just have to show you two tomorrow because I've been waiting. Like like January 3rd, when I was starting to think about this semester, I was like, I know what I'm going to show them, and I had to wait. So I've got this that I really want to show you guys. So hopefully you'll like the next one too. I think the next one's even cooler. It's not quite as easy to see like the trig stuff. But it is a visualization of that kind of stuff, and it's so cool. Can't wait. I'm glad you liked it. Good.
Mr. Rosengren, just one more thing.
Sure.
For part 2, graph 3, what would be like for C over B, so the phase shift, where would I start to find that?
Okay, let me share my screen so I can point at some stuff. Okay, so C over B is always, that starting point that we like depending on the graph, okay? And when we're looking at a graph like sine, remember, sine graphs start in the midline and go up, okay? And so I'm looking for a point along this midline. Hopefully you can kind of see that the x-axis kind of serves as the middle of this graph. I'm looking for a point on that line. And so I've got a bunch of choices. I've got this one, this one, this one, this one, or this one. But I want a point that right after that to the right, because we read graphs from left to right, I want it to go up from there, just like regular sine goes up. So I don't want to pick this point because it goes down, right? I don't want to choose that one necessarily. I don't want to choose this one because it goes down. I certainly want to choose this one because there's nothing over here. All right, so I really have two choices. I've got this point right here at negative pi, and I've got this point right here at pi because right after it goes up. Right after this one, it goes up. So you have a couple choices. Now, I think one of them stands out as being better than the other because if I have a starting point, it's really nice, if I can, to be able to see like the full cycle of sine go all the way through. Right? Same thing for cosine. If I was looking at cosine, I started at a maximum, go down. I want to make sure I can make my way all the way back up to that max if I'm looking at cosine. For sine, I want to start on the midline, go up, come back down, right? Go to the bottom and make my way back to the midline. So for me, when I was, because what I did is I made an equation and then I graphed it and then I just showed you guys the graph. I think the one that would be best would probably be negative pi as my C over B because it starts in the midline, it goes up, and I can find the end over here of that one full cycle. Because if I want to figure out the period, which is going to help me figure out the frequency, I need to be able to find the beginning and the end so I can see how long it takes to do that, right? What is the distance between a point like this one and the end point for that one cycle over here, right? And to figure that out, well, I'll just subtract the x values. I take the end x value and I subtract the beginning. So I start at pi minus negative pi, okay, so kind of like pi plus pi, so 2 pi. Right? That is the period, right? That's omega for this one. And then b is just 2 pi divided by that, okay? So 2 pi divided by 2 pi, well, that's just 1. And so I know my frequency is 1. Which kind of makes sense because in this length right here, which is a distance of 2 pi, right, from negative pi to pi is a distance of 2 pi, I only see one full cycle of sine. Whereas over here, right, clearly I'm seeing more cycles than just one in that period. Make sense?
Yes, thank you.
Cool, you're welcome. So just a couple minutes left. So if there's anything that stands out that you want me to work through, or answers that you want to see, or anything, any clarification that you want, now's the time. Or you can always, shoot me a message anytime, of course. I'm happy to look at stuff, and we can talk about it tomorrow. Tomorrow, hopefully, will be relatively quick as well. I just want to plot, I want to graph tangent, cotangent, secant, and cosecant, just so you have those somewhere, but we're not going to do any transformations of those. We got to talk domain and range for all of them. So hopefully I remember to do that. I've been trying to remind myself to do that for this whole week, to talk domain and range. But we'll do that tomorrow as well. So let me know if you have any questions. Otherwise, I'm going to log off in 2 minutes so I can go have some lunch. But give me a shout if you need anything. Otherwise, thank you all for hanging out. It was nice to have you guys hang out. It's always good to see you. So hopefully this is going okay. You haven't asked too many questions, so that's good. But I'm here, so let me know. Okay? I'm going to stop recording. Bye, Gracie. See you, Dan. Bye. You're welcome.